This is SpaceTime Series 28, Episode 14, for broadcast on the 31st of January 2025. Coming up on SpaceTime, a small asteroid visited to the Earth, most likely a chunk of moon rock. 2 lunar landers currently flying to the moon. And US President Donald Trump vows to plant the stars and stripes on the red planet Mars. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims that a near-Earth object discovered last year was likely ejected into space from the moon following an impact thousands of years ago. And now, this tiny space rock could contribute new insights into asteroid and lunar science. The small near-Earth object, known as 2024 PT5, captured the world's attention last year after it was discovered lingering close to our planet for several months. The 10-metre-wide asteroid doesn't pose a hazard to the Earth, but its orbit around the Sun closely matches that of our planet, and that hints that it may have an origin nearby. Now, a report in the astrophysical journal Letters suggests that PT5 appears to be composed of moon rock broken off from the lunar surface by a large impact event and then ejected into space. The study's lead author, Teddy Kurita from the Lowell Observatory in Arizona, says astronomers had a general idea that this asteroid may have come from the moon, but the smoking gun was when they found that it was rich in silicate materials similar to those found in lunar rock samples. The observations also suggest that this asteroid hasn't been in space for very long, maybe just a few thousand years or so. That's based on observations showing a lack of space weathering, which would have caused its spectra to redden. The asteroid was first detected on August 7th last year by the Sutherland South Africa Telescope of the University of Hawaii's Asteroid Terrestrial Impact Last Alert System, better known as ATLAS. Kurita and colleagues then used observations from the Lowell Discovery Telescope and NASA's Infrared Telescope facility on Mauna Kea to show that the spectrum of reflected light from the asteroid surface didn't match that of any known asteroid type. Instead, the reflected light more closely matched rock from the moon. A second clue came from observing how the object moves through space. Along with asteroids, space-age debris, such as old rockets from historic launches, can be found in Earth-like orbits. The differences in their orbits has to do more with how each responds to solar radiation pressure. Solar radiation pressure comes from the momentum of photons, quantum particles of light, which originate in the Sun, and they exert a tiny force when they hit a solid object in space. Now, this momentum exchange for many photons over time can push an object around ever so slightly, speeding it up or slowing it down. While a human-made object such as a hollow rocket booster will move like an empty tin can in the wind, a natural object such as an asteroid will be affected to a far lesser degree. To rule out 2024 PT5 being space junk, scientists at NASA's Center for Near-Earth Object Studies analysed its motion under the force of gravity and then any additional motion caused by solar radiation pressure. They found the solar radiation pressure effects were simply too small for the object to be artificial, and that suggests that 2024 PT5 most likely has a natural origin. In other words, it's an asteroid, not a disused rocket booster. The discovery of 2024 PT5 doubles the number of known asteroids thought to originate from the moon. Asteroid 469219 was found in 2016, also in an Earth-like orbit around the Sun, indicating it may also have been ejected from the lunar surface following a large impact. This is SpaceTime. Still to come, 2 lunar landers on their way to the moon, and US President Donald Trump vows to plant Old Glory on the red planet Mars. All that and more still to come on SpaceTime. SpaceX have launched a pair of landers on a Falcon 9 rocket on separate missions to the lunar surface. The privately developed experimental spacecraft include Firefly Aerospace's Blue Ghost and ispace's Resilience from Japan. The projects are part of NASA's Commercial Lunar Payload Services program, which is designed to deliver crucial hardware to the moon as part of the Artemis program, which is returning humans to the lunar surface in order to create a permanent presence on the moon before the end of the decade. The blastoff from Space Launch Complex 39A at the Kennedy Space Center in Florida went smoothly, with Blue Ghost deployed first, followed by Resilience 30 minutes later. The two spacecraft have different mission parameters and different timelines for getting to the Moon. Blue Ghost will gradually increase its orbit around the Earth until it also encompasses the Moon, taking a total of about 45 days. Now, this includes 25 days in Earth orbit, 4 days in transit to the Moon, and 16 days in lunar orbit. It will then attempt a landing near Mons Latriel, a volcanic feature in Mare Crisium on the Moon's northeastern near side. The spacecraft's carrying 10 NASA instruments, including studies into the Earth's magnetosphere and understanding how lunar regolith responds to solar exposure during dusk. It'll also be looking at the Moon's internal structure and its thermal properties. Blue Ghost is also carrying technology demonstrators, including a global navigation satellite system designed for use on the lunar surface and a radiation-hardened computer that will undergo testing in the harsh environmental conditions of lunar orbit. If it survives the landing, Blue Ghost will conduct 14 Earth days of surface operations. These will include lunar subsurface drilling, sample collection, X-ray imaging, and dust mitigation experiments. The lander will also capture high-definition images of a total solar eclipse from the Moon's surface, showing the Earth's shadow on the lunar surface. And it will also record data on how lunar regolith responds to solar exposure during dusk. Among the payloads aboard Blue Ghost is the Southwest Research Institute's Lunar Magnetotelluric Sounder, or LMS. It's designed to characterize the structure and composition of the Moon's mantle by measuring electric and magnetic fields. Magnetotellurics uses natural variations in surface electric and magnetic fields to calculate how easily electricity flows in subsurface materials, and this in turn can reveal their composition and structure. LMS's principal investigator, Robert Grimm, says that for more than 50 years now, scientists have used magnetotellurics on Earth for a wide variety of purposes, including finding oil, water, geothermal and mineral resources, as well as for helping to understand geological processes such as the growth of continents. But the LMS will be the first extraterrestrial application of magnetotellurics. The Mare Crisium landing site is an ancient 560 kilometre wide impact basin that subsequently filled with lava, creating a dark spot visible to the naked eye on the Moon. Mare Crisium is interesting because it stands apart from the large connected areas of dark lava to the west where most of the Apollo missions landed. These vast linked lava plains are now thought to be compositionally and structurally anomalous with respect to the rest of the Moon. LMS will allow scientists to probe the interior of the Moon to depths of more than 1,000 kilometres, 2/3 of the lunar radius. The measurements will shed light on the material differentiation and thermal history of the Moon, a cornerstone for understanding the evolution of solid worlds. The LMS works by ejecting cables with electrodes at 90-degree angles to each other at distances of up to 20 metres apart. Grimm says it then measures voltages across opposite pairs of electrodes, much like the probes of a conventional voltmeter.
LMS will be the first instrument from Southwest Research Institute to touch the surface of the Moon, and also the first in a series of projects that the Institute has operating under the CLIPS program. Our team at Southwest Research Institute, Heliospace Corporation, and NASA Goddard all contributed to this first extraterrestrial magnetotelluric measurement. The Lunar Magnetotelluric Sounder is a geophysical instrument designed to probe the Moon's deep interior and provide new information on the structure and geological evolution of our companion world. Magnetotellurics is a mouthful. Magneto refers to magnetic fields, while telluric in general relates to the Earth. Geophysicists use it specifically as a reference to electrical currents that flow in the ground. And so magnetotelluric together means measuring magnetic and electric fields. The signals that we're looking at from the solar wind and the Earth's magnetosphere have frequencies that are way below what you might be familiar with as radio waves. These signals take minutes or even hours to complete a single cycle. The benefit of these very low frequency signals is that they penetrate deeply into the Moon, and so they're sensitive to the Moon's internal properties. This allows us to determine the temperature and composition of the interior of the Moon. There are three main parts to LMS. The central electronics box was built by Southwest Research Institute. The magnetic fields are measured by a magnetometer that was built by NASA's Goddard Space Flight Center. The electric fields are measured between 4 probes that are deployed at 90-degree angles around the lander. These probes are sophisticated versions of those that you might use with a conventional voltmeter. Separations of about 100 feet are needed between the probes to detect a sufficiently large signal of the currents that are flowing in the ground. So we have to use a spring to launch out each of these probes to a distance of about 60 feet from the lander. These sensors and their launchers, as well as the magnetometer mast, were built by our colleagues at Aerospace Corporation. Although the moon is a relatively primitive body, geologically, its arrested development provides insights into the early evolution of other rocky bodies like Venus, Earth, and Mars. Since the Apollo era, we understand that the moon most likely formed from a collision between the Earth and a Mars-sized protoplanet shortly after these bodies first formed. The moon then formed from the debris of this collision and was likely initially totally molten. As it cooled and solidified, internal layering developed in the moon's rocky mantle, but this layering may have been later partially or fully remixed in the interior. LMS will be among the first geophysical measurements to assess interior properties of the moon since Apollo. LMS is both simpler to operate and has better performance than these Apollo-era experiments. We hope that LMS, other geophysical instruments on this mission, and those that will follow on other robotic and crewed missions will determine the three-dimensional structure and evolution of the moon. Although the South Pole is central to the whole Artemis program for its contrasting sunlight and shadowed regions, the most profound geological contrast of the moon is between the near and far sides. The near side of the moon, and specifically the western near side of the moon, contains most of the maria. These are the lava-filled impact basins. They're the dark patches that you see, and that's how we see a man in the moon, among other shapes. For some reason, volcanism that followed formation of lunar crust was not evenly distributed between the near and far sides. And the chemical composition of the crust on this western near side of the moon is also different from the rest of the moon. Yet, this is where most of the Apollo missions landed. And that leads us to question whether the Apollo results are representative of the whole moon, or are they different? The landing site, Mare Crisium, was selected to be outside of this anomalous region, away from the man in the moon, to enable LMS and LISTER to answer this question. LMS is the first of its kind instrument for planetary geophysics. Its demonstration paves the way for an even better version on a later CLIPS mission, as well as opportunities for other worlds, including Mars.
That's LMS Principal Investigator Robert Grimm from the Southwest Research Institute. Also aboard Blue Ghost are the stereo cameras for lunar plume surface studies, or SCALPs. It's an array of cameras placed around the base of the lunar lander designed to collect imagery of the rocket plume lunar dust interaction during the descent and touchdown. Using a technique called stereophotogrammetry, scientists will use the overlapping images to produce a three-dimensional view of the lunar surface at the landing site. An earlier version of SCALPs was fitted to the Intuitive Machines Odysseus spacecraft, which landed on the moon last February. However, it was unable to collect imagery of the plume surface interaction during the landing, although it did operate in transit and on the lunar surface following the landing. The new version has 2 additional cameras, 6 in total, compared to the 4 on Odysseus. It'll begin taking images at a higher altitude prior to the expected onset of plume surface interaction in order to provide a more accurate before and after comparison. See, the idea is that as journeys to the moon increase and the number of payloads touching down on the moon's surface near each other grows, scientists and engineers will need to be able to accurately predict the effects of the landings. How will the lunar surface change as landers come down? And what happens to the lunar soil, that is the regolith it ejects? SCALP's photogrammetry team scientist Olivia Terrell from NASA's Langley Research Center says this will be the first dedicated instrument to measure the effects of plume surface interaction on the moon in real time.
SCALPs is an array of small cameras that will be placed around the base of a lunar lander and collect imagery during the descent and landing of the vehicle. Using a technique called stereophotogrammetry, we can use those images to reconstruct a 3D shape of the ground. As the lander comes down, its hot engine plumes will interact with the surface. Our cameras will begin acquiring images from before this interaction begins until after the vehicle has landed on the surface. The SCALPS cameras will specifically be looking at the overall crater formation and erosion of the ground due to the rocket plumes. The final stereo images, which will be stored on a small onboard data storage unit, will be transferred to the lander and then downlinked to Earth, where we can use them to reconstruct the overall erosion volume and shape of the ground. So this information is important because as we send larger, heavier payloads to the moon and eventually onto Mars, we need to be able to accurately predict the effects of these landings. With the Artemis program, we plan to establish a sustained lunar exploration and try to land multiple payloads in close proximity to one another. SCALPS data will be a critical part of understanding these phenomena and improving our computational models to inform these future landings.
That's SCALPS photogrammetry team scientist Olivia Terrell from NASA's Langley Research Center. Blue Ghost is also carrying the Lunar Instrumentation for Subsurface Thermal Exploration with Rapidity, or LISTER payload, which will measure the flow of heat from the moon's interior. It uses a sophisticated pneumatic drill to dig some 3 meters down into the dusty lunar regolith. Every half meter or so as it descends, the drilling system will pause and extend a thermal probe into the regolith in order to measure the thermal gradient that changes in temperature at various depths, and thermal conductivity, that is, the subsurface material's ability to let heat pass through it. By making similar measurements at multiple locations on the lunar surface, scientists can reconstruct the thermal evolution of the moon, allowing them to retrace the geological processes that shaped the moon from the start as a ball of molten rock, which then gradually cooled off, releasing its internal heat into space. LISTER's mission manager Mike Selby from NASA's Marshall Space Flight Center says demonstrating the drill's effectiveness could lead to more innovative drilling capabilities, enabling future exploration of not just the moon, but also Mars and other celestial bodies.
We're naturally explorers, and we haven't been to the moon in over 50 years, and I'm excited about seeing us return and seeing a new generation be able to participate and learn more about the moon and being there for a longer period of time. LISTER is one of 10 payloads on the upcoming Blue Ghost Mission 1 lander. LISTER is an acronym standing for Lunar Instrumentation for Subsurface Thermal Exploration with Rapidity. It is basically a pneumatic drill with a needle sensor on the end to make temperature measurements. So LISTER is hoping to use the pneumatic drill capability to drill down in half-meter increments to make temperature and thermal conductivity measurements of the subsurface of the moon. With the goal of Artemis, or one of the goals being to establish a longer-term presence on the moon, instruments such as LISTER help us to learn more about the surface of the moon and how we can be there for a longer period of time and take advantage of resources available to us. Texas Tech is where the principal investigator for LISTER is located, and the payload was designed and built by Honeybee Robotics in Altadena, California.
That's LISTER mission manager Mike Selby from NASA's Marshall Space Flight Center. Meanwhile, the Lunar Environment Heliospheric X-ray Imager, or LEXI instrument, will try to understand how the Earth responds to space weather, the geomagnetic conditions in space driven by the sun. Once the dust clears from the lunar landing site, LEXI will power on, warm up, and direct its focus back towards the Earth. For 6 days then, it'll collect images of the X-rays emanating from the edges of Earth's magnetosphere, and it will study how this protective shield responds to space weather, the constant stream of charged particles flowing out from the sun, as well as other cosmic particles coming from deep space. LEXI will also look at the kinds of extreme solar events needed to penetrate the magnetosphere, allowing streams of charged particles in, thereby creating both auroral activity and also potentially damaging infrastructure through geomagnetic storms. LEXI will see the low-energy X-rays that form when the solar wind particles slam into the Earth's magnetic field. This happens at the edge of the magnetosphere called the magnetopores. Scientists have recently begun to detect these X-rays in a patchwork of observations from other satellites. But from its vantage point on the lunar surface, LEXI will see the entire magnetopores in its field of view. LEXI co-investigator Hounji Connor from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says she expects to see the magnetosphere sort of breathing in and out for the first time as it wobbles under the pressure of the solar wind pushing up against it. LEXI will also be poised to capture magnetic reconnection. That's when the magnetosphere's field lines merge with those of the solar wind and release energetic particles, which will then rain down over the Earth's poles. and this could help researchers answer lingering questions about these events, including whether they happen at multiple sites simultaneously, whether they occur steadily or in bursts. Connor says these solar particles streaming into the Earth's atmosphere cause brilliant auroral activity, but they can also damage satellites orbiting the planet and interfere with power grids, communications and navigation systems on the ground.
From the narrow field of view astrophysics observation, we've learned that our magnetosphere emits X-rays, which resulted in this LEXI mission. And I'm excited that LEXI will give us image from the lunar surface, that fantastic location. LEXI is a wide field of view soft X-ray telescope that will be deployed to the lunar surface. LEXI is designed to study magnetic reconnection, the process that allows solar wind energy to enter the Earth's magnetosphere. Changes in solar wind condition can trigger different types of magnetic reconnection, modifying the shape and position of the Earth's magnetosphere. These solar wind particles can be energized and creating space hazard for Artemis astronauts. And LEXI will be the first wide field of view telescope and observing this global interaction between solar wind and Earth's magnetosphere. Unlike the gigantic X-ray telescope sent by astrophysicists, LEXI is a small telescope. To get the global view of the magnetosphere, it's better to be far distant from the Earth. The Moon provides a perfect place to take the global picture. So understanding the solar wind and Earth's magnetosphere interaction is crucial for space exploration. LEXI's image will advance this understanding of global interaction between the solar wind and magnetosphere.
That's LEXI co-investigator Hoonji Connor from NASA's Goddard Space Flight Center in Greenbelt, Maryland. Onboard computers are critical for space exploration. They aid nearly all aspects of spacecraft function, from propulsion and navigation systems through to life support technology, science data retrieval and analysis, communications, and re-entry. Problem is, computers in space are all susceptible to ionizing solar and cosmic radiation, and just one high-energy particle can trigger a so-called single-event effect. That causes data errors and can lead to cascading malfunctions, system crashes, and even permanent damage. The Radiation-Tolerant Computer, or RAD-PC, technology demonstration aboard Blue Ghost aims to demonstrate computer recovery from faults caused by single-event effects. See, the computer is designed to gauge its own real-time state of health by employing redundant processors using off-the-shelf integrated circuits known as field programmable gate arrays. These tile-like logic blocks are capable of being easily replaced following a confirmed ionizing particle strike. Now, in the event of a radiation strike, RAD-PC's recovery procedures can identify the location of the fault and repair the issue in the background. It also carries 3 dosyometers in order to measure varying levels of radiation in the lunar environment, with each tuned to a different sensitivity level. The Lunar Payload Manager Dennis Harris from NASA's Marshall Space Flight Center says they'll also measure the interaction between the Earth's magnetosphere and the solar wind during its journey to the Moon and provide detailed radiation information about the Blue Ghost landing site.
I'm excited to maybe have a chance to build a bunch of low-cost computers that will work in any situation in the solar system. And 2, it's very exciting to really have an empirical understanding of the radiation environment on the surface. RAD-PC is designed to be a low-cost option to radiation-hardened devices that are currently in operation. Basically, it's a self-correcting PC that will allow low-cost, almost commercial off-the-shelf parts to be used in future missions. The science for RAD-PC is going to be twofold. 1, it's going to be how to self-correct low-cost computing on space missions. And 2, it's going to give us a real feel for the radiation environment, not only on the surface of the Moon, but through the Van Allen belts and through the entirety of the mission. So it fits in 2 ways. 1, it could allow us to have functional, low-cost computing power, not only on missions, but on the surface. The other way is that we're going to measure 2 different bands of radiation, a lower level and a higher level. That'll give us a much better feel for the radiation environment that the Artemis astronauts will be subjected to on their mission.
Back in the late 1960s and early 70s, Apollo astronauts set up a series of mirror arrays or retroreflectors on the lunar surface to accurately reflect laser light beamed at the Moon from Earth. Now, calculating the time required for the beams to bounce back allowed scientists to precisely measure the moon's shape and its distance from the Earth, both of which are directly affected by the Earth's gravitational pull. Now, more than 50 years later, as NASA prepares to return to the lunar surface, this time to stay with the Artemis program, a new generation of retroreflectors will be sent to the moon to continue the research. The next generation lunar retroreflectors, or NGLRs, will expand science's knowledge about the Earth's nearest celestial neighbour, its geological processes, properties of the lunar crust, the structure of the lunar interior, and how the Earth-Moon system is changing over time. This technology will also allow high-precision gravity testing using Einstein's theory of general relativity. And the first of the new retroreflectors will be deployed on Blue Ghost. A second new generation retroreflector will be carried aboard the Artemis 3 mission, which is slated to launch in late 2027, bringing humans to the lunar surface for the first time in more than 50 years. It'll be set up near the lunar South Pole. And a third new generation retroreflector is expected to be manifested on a future mission to a non-polar location on the moon. Dennis Harris says that once all three retroreflectors are operating, they're expected to deliver unprecedented opportunities to learn more about the moon and its relationship with the Earth.
The NGLR is a follow-on to the Apollo retroreflectors that have been on the moon since the 70s. It's more precise, it's a little bit larger, and it's designed to help us understand the movement of the moon. NGLR is designed to return a laser pulse that starts at the Earth, travels to the retroreflector, and then returns to the Earth. Large amount of science comes out of simple instrument like a retroreflector. So the two things immediately is we can measure the precise distance, but also it gives us information about the liquid core of the moon and how it moves, which will help the astronauts who will spend time there to understand their environment. I'm excited because this is a follow-on to the Apollo retroreflectors, allowing us to have maybe even 100-fold better idea of the precise distances to make our measurements more accurate and our predictions about general relativity and the interior of the moon more precise. NASA works in collaboration with the University of Maryland on the NGLR program. NASA Marshall's role is to facilitate the build, the test, the development, the design, and the delivery of the instrument to the lunar surface.
One of the more innovative technology demonstrators being carried aboard Blue Ghost is the Lunar Planet Vac, or LPV. It's a pneumatic compressed gas-powered sample acquisition and delivery system. In simple terms, it's really just a space vacuum cleaner that brings its own gas. It's designed to collect and transfer lunar soil from the surface to other science instruments or to a sample return container. The LPV sampling head will use pressurized gas to stir up the lunar regolith or soil, creating a small cloud which will then be sucked up into a transfer tube by secondary pneumatic jets and deposited in a sample container. Collected regolith, including particles up to a centimetre or so in size, can then be sieved, imaged and tested. Harris says there's no digging, no mechanical arms to wear out requiring servicing or replacement, and it functions just like a regular vacuum cleaner. The technology could also be used to search for water, helium and other resources, including in situ materials for fabricating lunar habitats and lunar launch pads.
One day we're going to live and work on the moon, and we need to know, is there any water? Are there any volatiles, any kind of chemicals that we can use for manufacturing? Say we want to build a landing pad. How can we use the lunar soil to do that? Lunar Planet Vac is designed to gather soil samples and either canister them up for a trip back to the Earth or to distribute them to any onboard instruments that might want to do in situ, and that is in-place measurements to look at the chemical composition of the soil. Space is limited on a rocket, and so is the mass. And so anything we can find on the surface that we can use to manufacture or build housing or launch pads is a benefit to the space program in the long term. The Lunar Planet Vac instrument will help us understand the environment on the moon and environments on other planets that we're going to travel to. The same company who's building Lunar Planet Vac is also have very similar instrument flying to Phobos on a different mission. So we're going to look at these different environments that we have to live in long term and understand them better. Lunar Planet Vac is a collaboration with Honeybee Robotics, a company based out of Palo Alto, California. NASA Marshall's role is to facilitate the funding, the design, the build, the test, and delivery of the LPV to the spacecraft for delivery to the lunar surface.
Once again, that's Dennis Harris. Now, we've been speaking a lot about Blue Ghost, but of course there's another spacecraft on its way as well from the same launch. That's the Japanese Resilience mission, which will take a more leisurely 4 to 5 months to reach its lunar destination at the Mare Fijoris on the moon's far north. Resilience's payload includes a four-wheeled robotic micro-rover equipped with high-definition cameras to explore the lunar surface, and it'll attempt to scoop up lunar regolith for study. This is SpaceTime. Still to come, US President Donald Trump vows to plant Old Glory on the red planet's surface, and later in the science report, discovery of what may be the world's oldest three-dimensional map. All that and more still to come on SpaceTime. America's newly elected President Donald J. Trump has vowed to plant the stars and stripes on the red planet Mars. The historic commitment was made during his inauguration speech at the U.S. Capitol building in Washington, D.C.
The United States will once again consider itself a growing nation, one that increases our wealth, expands our territory, builds our cities, raises our expectations, and carries our flag into new and beautiful horizons. And we will pursue our manifest destiny into the stars, launching American astronauts to plant the stars and stripes on the planet Mars.
Comments by POTUS47 were enthusiastically endorsed by his close ally, SpaceX boss Elon Musk, who envisages colonising Mars using his interplanetary colonial transport spacecraft, the Starship. Musk created a clip of himself raising two thumbs, grinning and clapping wildly as the president made his remarks. He hopes to send SpaceX's first mission to Mars on an unmanned flight next year. Earlier this month, Musk tweeted on X that we were going straight to Mars and that the moon is a distraction. During his first term as POTUS 45, President Trump launched the Artemis program, which will return humans to the moon as a stepping stone in order to reach Mars and beyond. However, China has also set its sights on both the moon and Mars. Beijing's planning a sample return mission to the red planet for 2028, and together with Russia, China's also working towards establishing a manned base on the moon in the early 2030s. Meanwhile, the American space agency NASA and the European Space Agency are planning their own joint sample return mission to Mars. That was originally slated for 2028, but it's currently been put on hold due to cost overruns, which are forcing a total replan. And there's also no firm date yet for a manned American mission to the red planet. The Artemis II mission, which will send astronauts in orbit around the moon, which was to take place last year, is now expected to launch in April next year. And as for the manned Artemis III mission to return humans to the lunar surface, that was also originally slated for 2024, but now is not expected to launch before September 2027 at the earliest. Needless to say, we'll keep you informed. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has isolated some of the risks associated with glucagon-like peptide 1 receptor agonists such as semaglutide, Ozempic and Wegovy. These drugs were originally prescribed for people with diabetes, but they've become more famous for their weight loss effects. Previous research has already shown that these medicines are associated with a lower risk of 42 different health outcomes, including stroke and heart issues. But a new study reported in the journal Nature Medicine looking at the effects of the drug on 216,000 people has also found an association with an increased risk of gut issues, including nausea, vomiting and stomach pain, as well as low blood pressure, fainting and arthritis. This kind of study cannot prove that these medications can directly cause the outcomes. But instead, the researchers suggest that people considering them should look into all the outcomes before deciding on their use. A key ingredient for fertilizer could one day be produced with zero carbon dioxide emissions. A report in the journal Joule claims the key would involve harnessing the natural power of the earth. Ammonia is the main component in many fertilizers, and there's hope that it could one day be used as a clean fuel. But currently, producing it's very costly to the environment. However, researchers believe that the natural high temperature and pressure below the Earth's surface could theoretically do the same job as today's industrial processes. So they built a rock-water reaction system mimicking this below-surface environment, and they say that when nitrogen-laced water came into contact with the rocks, it produced ammonia. The authors say that using this strategy in the real world would be logistically complicated and require much more research, but if it worked, it could be used around the world for a higher profit with no energy input and no CO2 emissions. Scientists have discovered what may be the world's oldest three-dimensional map. The find, reported in the Oxford Journal of Archaeology, was uncovered in a quartzitic sandstone megaclast in the Paris Basin. The Segognol Free Rock Shelter has been known since the 1980s for its artistic engravings of two horses in a late Paleolithic style on either side of a female pubic figuration. And it's now been revealed to also contain a miniature representation of the surrounding landscape. The new research suggests that part of the floor of the sandstone shelter was shaped and adapted by Paleolithic people around 13,000 years ago and modelled to reflect the region's natural water flows and geomorphological features. Before this discovery, the oldest known three-dimensional map was understood to be a large portable rock slab engraved by the people of the Bronze Age around 3,000 years ago, which depicted a local river network and earth mounds, reflecting a more modern map concept used for navigation. A Canadian politician in British Columbia has been using the title Doctor after she graduated from a mail-in online college calling itself Quantum University. It's the sort of school that exists in a Schrödinger-like state of being both real and not real at the same time. The big difference being this time when you look into the box, the doctorate she was awarded is virtually worthless in the real world, although it did cost her money to obtain it. Tim Mendham from Australian Skeptics says Quantum University isn't a real university, but part of a parallel system of pretend medicine allegedly influenced by quantum physics and New Age beliefs. And he warns that flaunting doctorates which aren't real can have concerning repercussions.
I immediately have alarm bells ringing whenever I hear quantum in a story. I have more alarm bells ringing when I go out there and talk to proponents of alternative medicine and things like that, who almost inevitably you can hear them, they'll quote quantum somewhere in their explanation for their particular modality. It's a catchword for strangeness, and we don't know how it works, but it works at a mysterious level. And you ask them what they mean by quantum and how it actually works, and they generally do not know. They know nothing about sort of quantum science and how it works, especially at the subatomic level, and not necessarily at dealing with someone's headache. But anyway, there's a university called Quantum University. Bingo, red flag, bells ringing. And a politician in Canada was claiming a doctorate or a doctor title because she graduated from this Quantum University. It's an online university. It's an online doctorate. You watch some videos, you do a bit of this, that, and the other, and it's totally unregistered. It's unqualified. It has no bearing at all on anything. So if someone comes to you and claims a doctor of something, you have to be very careful. You ask them where they got the doctorate from. You also have to ask them what their doctorate is in, because it's not necessarily medicine. You can be a doctor of literature or a doctor of all sorts of different things. Yeah, you have to check that.
I was asked to do a doctorate in astrophysics and astronomy.
Could have been interesting. Could have done that. Probably couldn't get enough big words to make it a PhD. But yeah, the term doctor is really misused. It's open to a lot of different people. The medical doctor with a GP qualification, etc., or specialist would like that doctor to be limited to that profession so you know what you're talking about.
Yeah, and the rest are PhDs.
Yeah, well, there's a medical doctor and there's a PhD, which aren't the same thing. And dentists use doctor, and now you're getting chiropractors using doctor, and you'll find a naturopath will use a doctor, and all sorts of things like that. So the term is being polluted in a way.
Dr. Dre?
Yeah, well, yes, a situation where the term doctor no longer has the same meaning, either because you get these shonky institutions that will grant you a doctorate, or you're getting someone who is not a medically trained person calling them, but we work in the quote medical unquote area, who regards themselves as a treater of people, and therefore that means doctor. The doctor term has problems with it, and quantum, the use of quantum has major problems with it by being used as a blunt weapon by those people who don't know what it is.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.